Hello, I'm Gil Gomez. I'm a teacher here at Eastside High School in our Biomedical Academy. Today we want to show off our Anatomage table that CTE purchased for us. This Anatomage table is a virtual dissection table that allows for us to use cadavers in a virtual setting so that we can show high school students the way that a medical school would do a dissection. This is an actual cadaver, and this person donated themselves for science. So let's take a look. So this is my cadaver here. I can take him and rotate him if I would like. And then I can actually take him from the superficial layers all the way down. So let's take a look at that. Here's my muscular system. Goes down to skeletal, some digestive, and then this is some of the cardiovascular. You can take it all the way back, just to show the different layers. Now, since we're doing a sheep brain dissection, we thought that we would show you the central nervous system and the difference between a human brain and central nervous system as opposed to a sheep central nervous system. So let's take a look at our different systems. So I'm going to choose the nervous system since that's what we're doing, and I'm going to have just the central nervous system. Now, what you'll notice in this central nervous system for a human is that here's the brain and the spinal cord comes directly down. Because we're standing on 2 feet, the spinal cord comes out the bottom of the skull. In the sheep brain that we're going to dissect, you're going to see that it comes out the back because the sheep is on 4 legs. Let's take a closer look at the different lobes and parts of the central nervous system. So here's the brain, and like the sheep brain, it has the same components. So up here on top, we have the frontal lobe, we have the parietal lobe, we have the occipital lobe, and we have the temporal lobe. We also have the cerebellum here in the back. So let's open it up and let you see what it looks like from the inside when it's actually dissected. So I'm going to use my scalpel, and I'm going to make a straight cut. Okay, now that we dissected it, we're going to remove some of the layers so you can see the internal structures inside the brain. So we're going to take the frontal lobe and remove it. We're going to take the parietal lobe and remove it, along with the occipital and the temporal. And we'll take the cerebellum off as well. Okay? So now that gives you a better idea of what's going on here with the cerebrum. And so these are your components that we're looking at. So here again is your occipital lobe. Here's your parietal lobe. Here's your temporal lobe. Your frontal lobe and your temporal lobe, and then these key structures inside like the corpus callosum. Okay, this gives us an opportunity to see a human brain, which we normally wouldn't be able to see, but this Anatomage table allows for us to see the internal structures as well as a human brain. We're going to move on to the sheep brain dissection, so take a look at this, and we'll make some observations of what's different between this human brain and the sheep brain. Okay, now we're going to show you how the Anatomage table lays flat and goes to a horizontal position so that you can have students or other people around as you do these virtual dissections. So I'm going to make a cut on this brain. I'm going to select the dissection tool. So now I'm going to select the structures that I want to remove layer by layer. Okay, so take a look at the brain. Here's my frontal lobe. I just removed that hemisphere. Here's my parietal lobe. Here's my occipital lobe. There's my temporal lobe. And there's my cerebellum. Now I can see the internal structures along with some of the endocrine pieces inside of here. So here's your corpus callosum. This is what the internal structure of the brain looks like, of a human brain. And we're going to take a look at the sheep brain to see the similarities and differences between a human brain and a sheep brain. All right, so again, we're super lucky to have that. CTE has been gracious enough to purchase that for us. And like I said, lots of med schools have them and colleges have them. I know ABC has one, we have one. So that's a big deal for us. So we're gonna do a lot more with that as we move through this course. And hopefully you guys will be on campus soon so that you guys can get an opportunity to use it. So here's what we're doing today on Canvas. It says, this is what we're doing. We're gonna see what are the functions of the main regions of the brain. We did some of that already in the last assignment. And so you should know some of those functions, but we're gonna be able to identify major regions of the brain. And like I said before, some of my background in athletic training comes in because if I know what the functionality of certain areas are, then I can assess the brain function or the brain, maybe a concussion or brain injury that takes place with somebody. So you're going to today take this document. It says students will do a sheep brain dissection, which really is me, but you're going to kind of watch it, to identify major regions of the brain. So students will use this sheet. So if you click on here, it will take you to this sheet. It'll force you to make a copy, and you will be given a sheet like this. Okay, so you'll all have a copy of that. Before we move on, I want to go back to my Canvas account and show you that you're going to turn it in here by midnight tonight. And if I click on this, you are going to see your rubric at the very bottom. All right, so here's your rubric. It says that you're going to get points for each one of these things that you labeled. It says the structure should be labeled and in the correct place. So make sure that you're doing it accurately and you will get points. Okay, and I'm going to take you through how to do that. But these are all of the things that you have to label, and they're 10 points each. And then there's a study picture. I'm going to explain that to you when we get to that point. But I want you to see this study picture that I have that you can use as a study guide for the next test. Okay, so let's go back to here. And this is the document that we're going to use. All right, so you are going to identify the following. It says parts of the brain, label them clearly on the drawing. I'm going to give you specific directions on how to do that because we are having issues with labeled drawings showing up with all of their labels. So I'm going to tell you how to make sure that we can see that. All right, so these are what we're going to identify. All right, and we talked a little bit about the human brain earlier. Now we're going to look at the sheep brain and see how closely related it is to a human brain. As you move down to the bottom, I gave you pictures. Okay, I don't want to ruin it for you. Okay, but there are pictures here under the portion up on top where it says to label the pictures. Okay, I'm going to show you how to do that, and then I'll explain to you exactly what I'm looking for to make sure that you get the points that you deserve. You're going to click on here. It's a Google Draw. I'm going to take this out because I want to. Sorry, I have so many things on my desk right now. I'm trying to use 2 different keyboards and all that other stuff. So take this out. Okay, so if I want to label this structure, what I'm going to do is I'm going to go over here to the drop down, and I like to use the arrow. So I might have an arrow here, and I might increase the size of this just so it's easier to see. I'm going to create a text box in here, and I'm going to type in here frontal lobe. Okay, we've done this before. This shouldn't be anything new to you, but I do want to make sure that I reiterate the next part, and that is once I'm done with labeling this, you can label, put the labels on either this one or the other view from the inside. Sometimes structures are easier to see, like the pons, the midbrain, from that internal structures, from the other one with the internal structures. But this, whatever picture you think shows these structures best is what you should use. Okay. Now, once I label all of these, I have to do a little extra to make sure that when I'm grading it, that the teacher can see it. Okay. I'm going to go to Actions once I'm all done, and I'm going to download this as a JPEG. Okay. I know that if I press Save, I'm going to be able to see it, but I'm telling you, when you submit it to me, they go away for some reason. So you're going to download that JPEG and then upload it again here and get rid of this other picture. Okay. Move down. Here's the one with internal structures. Today, before you leave, you should have almost every single thing labeled and ready to go. Okay. Now, this portion down here, this is what I was talking about, the study picture. So if I go back to my rubric, okay, it says got to change that. Each structure should be designed with designated with a letter so the picture can be used as a study guide. So if I go back up here to the top, and you'll see I put a letter next to each one. A is frontal lobe, B is temporal, C is occipital, right? And then all I did is that now I have a study guide that I'm creating. I come down here, click on here, and I say, all right, this is A, right? So when I'm studying, again, you're going to have to do JPEG pictures for these two. But as I'm studying, I might look at this and go, what is A? And then I can go back up to the top and use it as a study or as a answer key. Okay, so you're going to have either this or this picture. Between the both of them are going to have all of those labels in there. Okay. All right, so let's take a look at the dissection. All right, so here is the sheep brain. Okay, so when I was showing you the video from the Anatomage table that CTE paid for, what was the difference? There's two main differences I talked about from a human brain to a sheep brain. Okay, the size, of course. Sheep brains are very small, okay? And so you're going to see a difference between this sheep brain and an actual human brain. And what else? What was one of the other things? The spinal cord. Very good. Good job. So in a human, because we stand up on two legs, the spinal cord actually comes down like this out of the bottom of the skull. This one's going to come out of the back of the skull because it's a quadruped, which means that is on four legs where we're bipedal. And so this is going to be one of the major differences. Okay. So let's take a look a little bit at this. I'm going to use anybody ever see Dexter? Does this not look like a Dexter toolkit? Okay. Rosa, I knew that you had seen it. Okay. So here's what I got. And I'm going to try and manipulate this a little bit because it's kind of backwards on my screen. So I'm trying to look at the screen and do this at the same time, but I want to make sure that you can see the structures. So has anybody ever heard of meningitis? And they could get the meningitis shot before you go to college. So meningitis happens because on the brain, there's a covering called the meninges, and it's actually taken off of this one, but it's a very thin layer, and that becomes inflamed. Itis, meningitis, itis means inflammation of, okay? So it becomes inflamed and you lose some of the functionality. There are many things that can cause this, but they do give vaccinations against it. So when you get in contact with people when you go to college, it spreads rapidly. So they want to make sure that they kind of curb the spread of meningitis, okay? So some of the structures that we're going to talk about here can be seen from the external view. That you see here. You see some of these veins, some of these blood vessels, right? And what you'll notice is that there are bumps and grooves. So we haven't talked about this yet, so I want to give you a little bit of this information. So there are things called gyri and sulci, okay? And gyri are the parts that are actually out. And then the little grooves inside are the sulci. And so if you want to think about it as a fist, okay? If I'm looking at these areas here, this would be the gyri, the part that sticks out, and then this here would be the sulcus, okay? This groove area in here. So that's kind of what we're looking at when we look at the brain. Now, why does the brain have grooves like that? What's the reason for that? I know we haven't discussed it, but does anybody have any ideas of why the brain would have so many ridges? Okay, so one of the reasons is because we want to have a lot of surface area, right? If we were to lay this brain out flat, it would be about the size of a large pizza, okay? But because we have all these grooves, we kind of take it all and put it all into one spot. So if I was to take a sheet of paper and crumble it up, it would allow me to fit that piece of paper into a smaller spot, but still have the same surface area. So that's what's happening here. Somebody in my first period said, is that like the small intestine? It's exactly like the small intestine. And even more of that, it's like the inside of the small intestine. But all of that surface area helps with the functionality. So very, very important. Here's a fun fact for you. Mice have brains that are actually smooth. Okay, so if you had a sheep brain, if you had a mouse brain, it would look completely different because it would be smooth. But the structures would still be in place. All right, let's take a look at the internal structures. Please, I need you to have 213 document for today open, along with the one from yesterday that had all, or not yesterday, because we saw Phineas Gage yesterday. Last week, you had 213 with all of those different specific activities, but because we're going to talk about some of the regions and what they're responsible for. Okay, so as you pull that out, I'm going to cut this brain in hemispheres. Let me see if I can get this to focus if I turn it around. There it is. Okay. Oh, that's even better. All right. So here's the brain. It's a little wonky. Okay. This was in a pack that had it kind of laying flat. But what we're going to do is we're going to separate the right hemisphere and the left hemisphere. Okay. So we're going to right and left sides. So down the middle here, I'm going to cut down this groove, and I'm going to try and be very, very careful. So it may take me a second as I cut it, because I want to get you guys a good visual. Okay. I'm just going to kind of spread a little bit as I run it. This is super sharp. All right. And the frontal area is separated. Let me go back here to the posterior portion of the brain. And it's going to take a little bit of work here because I need to kind of make a turn and a cut. Okay. Almost there. There we go. If it was straight, it would have been a lot easier. However, there you are. Okay. So you can see the internal structures here. I'm going to kind of turn it so you have one view that has an outside or lateral view of it, and one that has a medial view. So let me see if I can. You know what? I'm going to actually flip this because I think now oh, there we go. It's going to be easier that way. There we go. Okay, so there's an internal and an external view. It's kind of weird because this doesn't always sit the way that I want. There you are. I'm going to separate them just so you can see where they're separated. It's a little weird on there. Okay. There you are. Okay. So now on your document, and I'm going to try and do two things here at once. So it might be a little bit different, and I'll move that around as I need to. Okay. But I want to go through your document. So the first thing that we're going to discuss is we're going to talk about the frontal lobe. Okay. So you're going to label this, okay, like I talked about. Here in the front, obviously in the front is the frontal lobe. Okay. And the frontal lobe, as we discussed, and you can put this in the chat window for me, what is the frontal lobe responsible for? If you have that document out from last week, it'll make your life a lot easier. Okay, Isaiah says characteristics. Anybody else? Personality traits. Okay, so in the frontal lobe, if you were to have an injury to the frontal lobe, you'd have issues with a couple things. One is this is the area that's responsible for happiness. Okay, there's a part in there called the amygdala. And so the amygdala is the specific region, but in the frontal lobe is responsible for happiness. Speech production takes place in the frontal lobe. Movement takes place in the frontal lobe, in the motor cortex, which we'll talk a little bit about. And then as we move down, the long-term memory takes place in the frontal lobe, specifically in the hippocampus. And taste. Taste is in that area along with problem solving. Okay, so these are things that you're going to need to know for the quiz. So I want to make sure that we're going over those just so that we can review. All right. So on your sheet, the next thing is your temporal lobe. And so if you think about where your temple is, here's your temporal lobe. Sorry, I'm trying to look at the brain and the screen at the same time, and my eyes don't do that. All right, so here's your temporal lobe. You're going to go ahead and label that. And somebody in the chat window, let me know what temporal lobe is responsible for. Marissa with language understanding, good job. Okay. Queenie, good job with hearing. Okay. Remember the ears, your ears are right there by the temporal lobe. So your sensations are right there for hearing. When I talked about being an athletic trainer, we would hear athletes all the time come to the sideline and say, I hear ringing in my ears. You got your bell rung. You've probably heard that before, that term. So we know that we can pinpoint certain parts of the brain that are having some issues with a concussion. Okay. Long-term memory. Good job. Okay. Very good. Good job, you guys. So then the next thing is occipital lobe. What takes place in the occipital lobe? And in this, before you answer that, I'm going to kind of separate a little bit. Okay. And this right here, this is not the occipital lobe. It looks a little bit different in the human brain. This portion here, which we'll get to, is down here on the bottom. But the occipital lobe is going to be this back area in here. Okay. Kind of where it separates. Okay, Rosa, good job. Vision takes place with the occipital lobe. Okay, so vision. And if you want, you don't necessarily have to, but in that document I gave you up on top, if you want to just write those in, you can write them in. Be another cool study guide for you guys. All right. Parietal lobe. Parietal lobe is going to be more here up on top. Okay, kind of up on top of that temporal. Okay, but this is going to be your parietal lobe in here. And from our review, what happens in the parietal lobe? Okay, good. Body sensation. So things such as touch, temperature, pain is going to take place in that parietal area. Okay. So again, if you want to put that on your sheet, you can. But I want you to have this as your study guide for structures more than functions. But if you want to utilize it for both, even better. Okay. Let's move down to the next part, cerebellum. Okay, cerebellum and cerebrum for people. People have issues with because they sound kind of similar. So the cerebellum is going to be this back part here. Okay, this is my cerebellum. Right. So what is the cerebellum responsible for? I see muscle coordination. Rosa, movement really, muscle coordination is in the cerebellum. And then you do have balance that takes place in the cerebellum. Okay, those are two major components or two major functions for that, that structure. All right. So cerebrum is where people kind of get thrown off. Where's my cerebrum in here, in this brain? Okay, we had cerebellum back here. Where's my cerebrum? This one's a little tricky. This one's going to be hard for you to identify, but you can put like a little note on the side. Remember that the cerebrum is basically where all those lobes are. It's that portion there. So you're talking about where the frontal, the parietal, the temporal, and the occipital lobe are. They're all contained in your cerebrum. Okay. Brainstem. Okay. I'm going to start looking at this internal view. Okay. Here's my brainstem. Okay. Here as it moves down. So you're going to just label this as your brainstem. Okay. Kind of easy to remember. It looks like a stem more than anything else. Okay. But along that brainstem, you're going to have a couple things. And so let's label those real quick. Number one, let's go back first. I forgot the motor and sensory cortex. When I look at this here, okay, this outside view, you're going to kind of see an area in here. And normally when we build these brains in our mannequins, we put a little spot here that's brown and it goes across this way. That's where our motor cortex is. And just like it sounds, motor cortex is responsible for movement, okay? Right behind that would be your sensory cortex. And like I said, these brains don't show up very well. However, they would be right here kind of on the border of the frontal lobe and this parietal and temporal, okay? So sensory obviously is going to have to do with senses. Right. Now, let's take a look at this internal structures. When we're talking about the next thing, which is the midbrain is going to be right around in here, kind of at the top of that brain stem. Okay, that spinal cord where it comes in. This is really your midbrain as you are up on top. So I'm going to give you a second to just identify that. I don't want to leave anybody behind. Okay, and then as we move down, we are going to move down to the pons. Okay, and the pons is going to be right in this area in here. Okay, my pons area. And then right below the cerebellum here, you're going to see the medulla. And the medulla is going to look a little different in the sheep too. The medulla is a little flattened out in these, and that has a lot to do with how the spinal cord is oriented. And then obviously the spinal cord down here completes your central nervous system of the brain. Then you have your spinal cord that goes down. So your central nervous system is all contained here. All right. What's the other nervous system? Okay, very good. The peripheral nervous system. Good job, you guys. Raven, Marissa, good job. Peripheral nervous system, remember, are going to be the nerves that kind of come off that spinal cord. Okay, so with that said, this sheet with all of the labels on them is due at midnight. Please remember to submit it by midnight, and remember to download those images as a JPEG and then insert them in. Otherwise, I will not be able to see them. Please also remember that look over your rubric prior to turning it in to make sure that you have everything you need in order to get full points. Okay. This sheet here, you can turn it in as a PDF if you would like. I think it actually is making you do a PDF. So please make sure that you do it in that format. And then again, make sure you're looking at your rubric prior to turning it in. Do we label all the pictures? Queenie, you're going to have some structures. You're going to have labels on every one of those. It just depends on which ones the structures are easier to see on. So, for instance, the midbrain, the pons, things like that are going to be difficult to see from the outside view. So you're going to have to use the inside view to do that, even on the study guide portion. Now, today is a short day, so we're going to get out of here earlier than normal. It's currently 9:33, and we are done at 9:35. Okay, so if you have questions, email me. We usually are at office hours. However, today is Wednesday, and we have meetings, so we won't be in office hours today, but feel free to email me. And then if you really, really are struggling, you can come into office hours tomorrow. But I'm allowing you to turn in until midnight in case you have any issues with Wi-Fi or any of those type of things. I'm gonna take this video and put it on the agenda today, so that in case you have to do a review, it'll be there for you. Okay. So you guys have a good day. If you're leaving, if you have questions or need help, stick around for a second, and I'll try and help you through those.